Imagine you're out in the wild, surrounded by animals fighting to survive each day. Ever wondered how they do it? Some animals can change their skin color, others can hibernate for months, and a few even use tools just like us. But these adaptations aren't random. They're nature's way of equipping each species for the ultimate game of survival. In this video, we'll uncover the mind-blowing, sometimes bizarre adaptations that animals have developed to outwit predators, find food, and survive in extreme environments. Stick around to find out how these adaptations work and what makes each one essential for survival. Animals' survival strategies are fascinating, complex, and diverse. Each species has evolved in response to the specific challenges of its environment, resulting in specialized traits and behaviors that give it a competitive edge. Here's a deeper look into some of these remarkable adaptations. 1. Camouflage and mimicry. Camouflage isn't just a matter of blending into the background. It involves a highly specialized set of adaptations tailored to each animal's habitat. For example, the snowshoe hare changes its fur color seasonally, from brown in the summer to white in the winter, to stay hidden from predators against different backdrops. Some animals employ disruptive coloration, where their patterns break up their outline and make it harder for predators to distinguish them from their surroundings. In the ocean, octopuses and cuttlefish can change not only color, but also the texture of their skin to mimic rocks, coral, or sand, an adaptation that lets them ambush prey or evade predators. Mimicry, on the other hand, takes this a step further by copying the appearance, sounds, or behaviors of other organisms. The harmless scarlet king snake, for example, resembles the highly venomous coral snake. This mimicry tricks potential predators into avoiding the king snake, thinking it's the dangerous coral snake. Some insects, like the hoverfly, mimic the look of bees or wasps, giving them protection despite being harmless. 2. Structural adaptations. Structural adaptations refer to physical features that have evolved to meet environmental challenges. Birds have hollow bones to reduce their weight for flight, while penguins have solid, dense bones that act like diving weights, helping them swim underwater. Predators often develop claws and sharp teeth, like the jaguar, which has powerful jaws capable of cracking turtle shells. Herbivores, on the other hand, tend to have flat, grinding teeth suited for breaking down tough plant material. Many desert animals, such as the fennec fox, have large ears that radiate body heat and help cool them down. In rainforests, animals like sloths possess long limbs and curved claws to hang from trees and move with ease through the dense canopy. 3. Behavioral adaptations. Behavioral adaptations allow animals to avoid predators, conserve energy, or better access resources. Insect-eating bats hunt at night to avoid diurnal predators and find food with little competition. Some animals have developed complex group behaviors, such as meerkats taking turns as lookouts to warn the group of approaching predators. This behavior minimizes individual risk and keeps the entire group safe. Other behavioral adaptations include defensive posturing and displays. For instance, the frilled lizard expands its neck frill to appear larger and more menacing when threatened, deterring potential predators. Migratory behavior is another essential adaptation, seen in animals like the monarch butterfly, which travels thousands of miles to avoid cold weather and find food sources. Wildebeest, zebras, and other herbivores migrate across African savannas following rain patterns to access fresh grazing areas. 4. Physiological adaptations. Physiological adaptations allow animals to survive extreme conditions and environments. In the cold Arctic, animals like polar bears have a thick layer of blubber under their skin, not only to insulate against the cold, but also to provide energy reserves. Their black skin absorbs heat from sunlight, while their white fur provides camouflage in the snow. Desert animals like the kangaroo rat have adapted to survive without direct water intake, obtaining moisture solely from the seeds they eat and producing highly concentrated urine to conserve water. High-altitude animals, like the Andean condor, have adapted with large wingspans for efficient flight in thin air and a higher red blood cell count to maximize oxygen intake. Some animals can tolerate extreme temperatures. Arctic fish, for instance, have antifreeze proteins in their blood to prevent their body fluids from freezing in sub-zero temperatures, allowing them to live in icy waters where other fish would not survive. 5. Hibernation and estivation. Hibernation and estivation are survival tactics for dealing with extreme temperatures and resource scarcity. Hibernation is a form of deep sleep used by animals like bears, bats, and groundhogs during winter. During this time, their body temperature drops, heart rate slows, and metabolic rate decreases, allowing them to survive for months without eating. Estivation, used by animals like lungfish and certain reptiles, occurs during excessively hot or dry periods. The African lungfish, for instance, buries itself in mud and secretes a mucus cocoon to retain moisture, remaining dormant until rains return. 6. Reproductive strategies. Reproductive strategies vary widely among animals to ensure the survival of their species. Many fish, like salmon, lay thousands of eggs, knowing only a fraction will survive to adulthood. By sheer numbers, they increase the likelihood that some offspring will make it. Some animals, like emperor penguins, rely on parental cooperation and dedication, with both parents sharing the responsibility of incubating eggs and foraging for food in harsh Antarctic conditions. Other species synchronize breeding seasons so that all offspring are born at the same time, flooding the environment with young and overwhelming predators. A few animals even exhibit parental sacrifice. In some spider species, like the black lace weaver, the mother allows her offspring to consume her body to provide them with essential nutrients for growth. 7. Tool use and problem solving. Tool use is an advanced form of adaptation that requires problem-solving skills and creativity. Primates are among the most famous tool users, with chimpanzees using sticks to fish for termites and rocks to crack open nuts. Elephants have also been observed using sticks to scratch themselves and swatting flies with branches. Sea otters crack open shellfish by smashing them on rocks they balance on their stomachs while floating on their backs. This behavior shows a deep understanding of cause and effect and gives these animals access to food sources that are otherwise difficult to reach. 8. Social structures and communication. Animals that live in social groups often develop sophisticated communication systems and complex social structures that improve their chances of survival. Wolves hunt in packs, which allows them to take down larger prey than they could manage alone, and they communicate through a combination of howls, body language, and scent marking to maintain pack cohesion. Elephants communicate through low-frequency rumbles that can travel miles to keep herd members connected. Dolphins and whales use echolocation to navigate and locate food, and some have developed unique vocal signatures to identify each other individually. Cooperative hunting is another advanced adaptation seen in animals like lions and orcas. By working as a team, these predators can tackle much larger prey, improving their hunting success. 9. Predator-prey arms race. The predator-prey relationship drives continual evolution, creating an arms race of adaptations. Cheetahs are the fastest land animals, but their prey, like gazelles, have evolved agility and stamina to evade them. Some prey animals develop defensive features, like the thick hide of the rhinoceros or the sharp spines of a porcupine, to dissuade attackers. In response, predators might evolve sharper claws or powerful jaw muscles to pierce tough defenses. Some prey animals have developed ways to fight back directly. Bombardier beetles, for example, produce a chemical spray that can burn or irritate predators, while skunks release a foul-smelling spray that deters most attackers. Prey animals that can't fight back may have acute senses, like the wide field of vision in rabbits, which lets them spot threats early and escape. Final thoughts: adaptations illustrate the resilience and creativity of life on Earth. They're not just mechanisms for survival, but also for the success and proliferation of each species. From the tropics to the tundra, each adaptation tells a story of the challenges that animals have faced over millennia and their remarkable solutions to keep moving forward, even when the odds seem insurmountable.